polar coordinates. What are they? Well, if you consider polar coordinates as regular point on an xy plane, it can be so confusing. We are using r and theta, but we are graphing it on a xy plane. Well, so let's just compare the difference between the regular rectangular coordinate. Okay, so coordinates in rectangular form, well, or the rectangular coordinate is actually the name we have for the regular x and y. Okay, well, sometimes they call it as Cartesian coordinate. Cartesian or rectangular, they're the same thing, x comma y. And we know exactly how to plot the point when you see 1, don't you? If you see 2 comma 1 or negative 5 comma 2, you know that you have to go horizontally by and vertically by, depending on what comes first and what comes later. For instance, this point, I can mark it as 2 and 3, hence 2 comma 3. That's your x comma y. However, polar coordinate does not point the, well, find the position of the point using the horizontal and vertical distance. Instead, okay, they measure the direct distance from the point and the origin. And what they do is they measure the angle from positive x-axis. Hence, that is your r, and that's your angle theta. All right, so the thing is, the r is actually rather easy because it's simply the distance between the point and 0, 0. Everybody knows how to find the distance between a point and a 0, 0, right? The angle, this can be a little tricky for many reasons actually. Well, number one is that the angle measurements have to start from the positive x-axis, so that if you are measuring the angle, remember this way, you're measuring it in positive way. If you do it the other way, then it's in negative way. So, and again, if you go one round and goes further, it's the same thing as just going, right? Hence, 30 degrees equals to 390, right? And more. So angles can be a little bit more complicated because there's no just like one way of showing the position in terms of angle. There are so many ways to show that because of the coterminal rule technically. All right, now, so the general definition for r and the angle, knowing the x and y of the point is, well, you can consider having x comma y for some real values of x and y. Then the distance between the point and 0, 0 can be given by calculating the distance using the x and the y as the two legs of the right angle triangle. So simply you just form a right angle triangle and you do what you do the best. Pythagorean theorem, everyone's favorite, because, well, then r squared, right? Your r will be equal to x squared plus y squared. Hence, your r in general will equal to square root of x squared and y squared. So that's how x, y, and r and theta is related. Okay, or angle, it's related from the same right angle triangle. If you consider this and knowing the two legs, okay, guys, remember what this is? The opposite, and that's the adjacent. The ratio that we used for opposite and the adjacent was tangent. So, knowing that these are given, right, we may do tangent inverse of tangent for y over x. That will give you what your angle is. However, this formula is a little scary because if you consider 1 comma 1 as x and y, as well as negative 1 comma negative 1, right? They will both say inverse tangent of 1, doesn't it? Because, you know, the negative cancels. Hence, it will come out as 45 degrees in your calculator, or pi over 4 radians. It's just that you know that 1 comma 1 does have an angle of 45, right? 1 and 1, it's right here. However, negative 1, 1 is over there, isn't it? It's down here. How is this 45? It's actually 180 more than 45, isn't it? It equals to 2 to 5. The angle should be 225 degrees for this and 45 for this. So what shall we do? If you're looking for the angle, could you just make sure that you graph it? Because if you think about it, remember how tangent is positive from here on the in the first quadrant as well as the third quadrant. Remember this, all sine, tangent, and cosine. Remember, like the angle, if the angle lies here, right, it's also positive. Hence, the ratio is still the same for this angle and that angle. So it can be confusing. So, just make sure that you simply sketch the graph for the point, and you should remember that the angle has to be measured from here, this way or that way, if you're measuring it in negative direction, so that the you don't get confused, right, for having a simple 45 degrees for negative 1, negative 1. So again, this is something that you can just use and apply. However, this, you must check, right, in what quadrant the angle is by graphing it. Okay? So this, it's better off done by the right angle triangle. Okay, now, what about it is the r and the theta that you have, and you are looking for the x and y from it. So it's the other way around. So the equation above is something that you may use if you're looking for the r and theta, knowing x and y. And this is the other way around. Okay, now, same point, right? But now, what you know is the distance, and what you know is the angle. So how do we use this to find out the x and the y, right? Again, we actually are using the same exact method as before. What you do is you make a right angle triangle from it by just simply putting a vertical line from the point to the x-axis. And since this horizontal distance and the vertical distance is our x and y, what you can do is set up another sine ratio and cosine ratio, because this time what you know is the hypotenuse, and what you're looking for is the opposite and the adjacent. Hence, sine of the angle will equal y over r. Cosine of the angle will equal to x over r. So your y equals to r sine, and your x equals to r cosine. This is your general equation or formula for your x and y, knowing or using the r and theta. All right, so formulas are important, but you may still get them from creating a right angle triangle after you plot the point. You just need to know how to plot them. How do we plot them? Again, so if you're given 2, 100 degrees, for example, all you have to do is go 100 degrees from where? From positive x-axis, right? And mark a point 2 distance away from the origin. So this is where 2, 100 degrees is. Okay, just one more. If you're looking for 1, 30 degrees, negative, let's go for negative, then what you're doing is you're going 30 degrees, but below this time, and you're measuring 1 unit from the origin, then here comes your point. That's where your point is, and that's where your point is. 2, okay, length of 2 and length of 1. Quite simple, isn't it? So that's how we plot r and theta, and this is how you convert them. Right angle triangle is something that you just have to create. It makes everything so much easy. Okay, now angles though, like I said, is a little more complicated because they do have coterminal angles and reference angles. So just, knowing the position does help out a lot. Okay, so let's talk about finding actually the polar coordinate or the rectangular coordinate. Okay, let's do 1 comma negative 1. Though I didn't say it, you should know that this is the regular x and the y, right? So what you do is you may use the formula, but for the angle part, remember I told you not to use the formula for the angle because of the reference angle rule. What you do is you just mark here 1 comma negative 1, so it should be down here, right? And what you have to do is you may just create a right angle triangle. Always, connect the point to the x-axis. Then use the x and the y as the two legs. So technically, the hypotenuse, right, is obviously square root of 1 squared plus 1 squared, hence 2. That's your r. Now, what is the angle? As you can see, this is an isosceles right angle triangle. So we do know that the angle right here should be 45 degrees. But if you are writing it properly, remember if you're measuring it this way, that is basically negative 45. If you are to measure it from here, then you are going all the way around like this, which means it's actually 45 degrees shorter from being 360. So that is technically 315 degrees, right? I mean, there are many other ways we can write this, and more technically. That's why polar coordinate can be a little bit more, irritating because there's no like the single angle that we can use. There are a bunch of them. So technically when they do ask you to find the polar coordinate for this, instead of like asking, which of the following is the right polar coordinate, they ask for which of the following is not right polar coordinate for the given rectangular coordinate. That's what they ask. You may just simply calculate them, but also you can just find the position of each angle and find out the one that does not, stay in the same position. That's the easiest way. Now, there is negative 2, 2 root 3. So what do we do? For second example, I have put irrational number, but not a big deal. Just, find out the position. The position of, of the point is, somewhat important because that defines what the angle is. So negative 2 and positive y basically means that the point lies somewhere here. So just mark 2, 2 root 3 right here. And then create a right angle triangle and use the values as the 2 legs, 2 horizontal, 2 root 3 vertical, right? And as you can see, then, do you see this? It's x and square root of 3x. It's a special right angle triangle. You know what that means? It means that the ratio of this is 1 and this is square root of 3. Then the ratio for this part will be 2. Well, we can prove it. We can actually do Pythagorean. What is this? The missing r should equal 4 plus, ugly 4. Here we go, 4 plus square of that is 4 times 3, 12, which is 16, right? So that equals to 4, because you have to do square root of that. Okay, now as you can see, the ratio is 1 to square root of 3 to 2. It is a special triangle, and if you remember the angles correctly, across from your 2, there should be 30 degrees, and the adjacent should equal 60 degrees, right? The shorter the side, the smaller the angle, the smaller the opposite angle. Okay, anyways, so we have found out what the r is, and knowing the special ratio, we know that this angle equals to 60. Hence, the angle measurement that we are looking for will be 120 degrees. And we can go like the other way around and one more round. And so there are more than, one answer for the angle part. So the second example has 120 degrees for one of the many answers that you can write. Okay, last question, 3 and 4. 3, they're both positive, so it's here, 3, 4. Make a right angle triangle, 3 and 4. Ooh, it's like one of the set of values that people do know by their heart, right? 3 squared, 4 squared, they sum to 25. The angle right here will be given by tangent, right? So inverse tangent of 4/3 will be equal to your angle, and again plus many more. I may add this by any multiples of 360s, those will be correct as well. Okay, so this is how you look for the polar coordinates, knowing the rectangular coordinate. And, please do remember that angles will change depending on what, you add this by. You can add this by any multiples of 360s, or, by 2 pi's if you're looking for the angle in radians measure, which is actually, they do use radians quite a lot. So, get used to it as well. All right, now, there's one thing before we move on to the next set of examples that I want to discuss with you. The distance r should be positive, right? So if you have, for instance, I'm going to use this for our first example. So from this, we know that one of the polar coordinate that we can use is square root of 2, comma 315 degrees, right? The thing is, for polar coordinate, we may write negative r. When that happens, your angle changes, right, by 180 degrees. Well, just consider this. Let's say you're given r and an angle, and you have found the position of that point. Say that point was right here, right? This point is equal to negative r, comma, angle plus 180 degrees, or half pi. Basically, pi. Here we go, 180 or pi. So that if you have this or this, it doesn't matter. They both mean the same position for the point. So it's funny, for polar coordinate, they do convert r into negative r, and when that happens, your angle will have to change by 180 degrees. Okay, so if I wanted to write this using negative root 2 instead of positive root 2, I will have to subtract 180 from here. So technically I'll be having 135 degrees, sorry, 35 degrees. Okay, so differ by 180 degrees. You may, add it or subtract it, doesn't matter. I decided to subtract it because I prefer smaller values. So again, there are infinite many ways of showing the polar coordinate. It's not just changing the angle parts. You may change r into negative r as well. That's actually quite important. Let me just rewrite it. Okay, so one more time. If you are given r and theta, it's the same thing. You may rewrite this into any multiples of, right? By adding any multiples of 360 degrees or 2 pi radians, as well as converting r into negative r will give you 180, right? Or pi. And again, any number of coterminal angles of that too. So plus or minus, it doesn't matter. Okay, so just remember this. Add or subtract by 180, right? Will let you convert r into negative r. Okay? All right, now, so let's move on to the second part of the examples. So we were doing polar coordinates until now. Let's use the polar coordinate in order to look for the rectangular coordinates. Okay, so now you need to remember how you find the position of the point in terms of polar. What do? We have to measure the angle. 180 degrees goes which way? It's negative, so it should go this way, right? So it needs to go this way, and it has to stop somewhere here, because this is negative 180 if we go all the way. So you need to go this much and stop, and then you have to start measuring and stop when you have reached 10 units long. So this will be the position of your point. All right, now, if that is your position for the point, what can we do to get the x and the y? Well, the x and the y, again, is given by the right angle triangle. But for this one, you may just use the formula. You may just go without doing all this. You can actually go, oh, I know that x equals to r, which is 10, times cosine of negative 150 degrees, and y equals to r sine of negative 150 degrees, right? So you can just, find these out. Hence, it will tell you what your x and y is. It's actually rather easy. Converting rectangular into polar, it's so much, it's so much harder than the other way around. Okay, so use this, or you can graph it if you want. Since this is 150, the right angle triangle you create will have 30 degrees. Oh, you know what that means? It means special triangle all over again, since the ratio is 1 to 2 between the shortest leg and the hypotenuse. Then, that gives you this as 5. Hence, this is square root of 3 times 5, 3, and this is negative, and that's negative for obvious reason, right? The position of the point lies in the third quadrant where both x and y are negative. So either you do it this way or this way, you do get negative 5 root 3 comma negative 5. That's your x and y for question A. And for the, you may use the same rule for the next two as well. Many people do prefer understanding angle in, degree measurement, because we are not very comfortable using radians measures, right? However, if you just think about this, pi over 4 is simply a quarter of a way of being a pi. Remember how this is pi? So if you just divide your, quadrant into quarters, right? First quarter is basically exactly 45 degrees. So what I'm trying to show you is that you don't have to convert this, into degree using calculation. You may simply cut the quadrant up and just count how many quarters or how many sixes, there are. It's actually easier for you to count this way. So anyways, so your point lies quarter of a pi way for 4 units. So that's pi over 4, and that's 4. And obviously, since this is 45 degrees, this is 45 as well. So it's an isosceles right angle triangle. And the ratio is 1 to root 2. You know the ratio? So technically, what you have here is 4 over square root of 2 for x and for the y. And if you want to rationalize it, you will get 2 root 2, right? So your x and y is 2 square root of 2 comma 2 square root of 2. Okay, so let's do the last problem, C. Okay, so this is slightly tricky because what we have here is negative 2 and 3 pi over 2. Again, I told you to just count pi over 2. Well, isn't this half pi, right? All the way is pi, right? This is half of a pi, 2 halves, 3 halves. We are talking about right here, right? However, remember what I told you? That technically has to change into positive 2 comma another angle, which is differed by pi. I told you to add or subtract it by pi, remember? Hence, 3 pi over 2, when it's subtracted by pi, becomes just simply half of a pi. So your point is not down here, it's actually up here, 2 units away from 0, 0. So the x comma y for this is 0, since the position in terms of x is 0 and y equals to 2, so 0 comma 2. So That's how you can convert negative r into positive r. Since we know the position of the point in terms of positive r, convert that, hence change the angle, hence get the x and y, okay, from that point. Okay, so converting, though it can look complicated at first, and it's usually complicated just because it's a new concept, isn't it? If you're given x and y, anyone who has taken like middle school math knows how to graph x comma y, but not many people knows how to graph polar coordinates. That is the only reason that might cause this to look hard. However, if you think about it, r and theta is simply the distance and the angle. You may use the right angle triangle if you have to. It's so simple. Just understand, if you know your SOHCAHTOA, there's no reason why you should avoid doing these questions. Just remember what r and theta meant. That's all you have to do. Okay, so coordinates. When it comes to coordinates, you need to understand the direct relationships between x and y and r and theta. However, coordinates are not the only thing that is, covered for this lesson. You have to also understand the equations of polar. Polar equations are important for calculus, actually. For pre-calculus or for SAT subject test, only the basics are covered. Graphing is also important, but we don't graph them by hand. We always use graphic calculator. The polar coordinate is given as r and theta, right? Well, the thing is, angle here is your input, okay? So what happens is that you're solving for r when it comes to the equation, and you will get such as sine theta. You will get a function equation in terms of theta. This is an example of a polar equation. It looks as r equals to some equation in terms of the angle. Okay? And what you need to do is, if you're using TI or any other calculator, there is a mode button. And if you go there, instead of graphing, it's basically you go to the mode and then graphs and change your graphing mode from function to polar by just entering, on polar. Then if you press y equals to, you will see r equals to, blanks instead of y equals to. You just simply change your mode from your calculator, then, type in whatever equation they're giving you. That will give you the graph. Oh, by the way, but there's one thing that I want you to double check. Okay, so I'm just telling you this, just thinking that you guys are using TI calculators, 84, 89. Okay, so after you change your mode into polar mode, before you enter graphs, after typing in your equation, could you please check your window before you do that? Because your input now is the angle, right? Your angle should change depending on what the angle mode in your calculator is set as. If your calculator has a degree mode, then your minimum and maximum value should go from negative 360 to positive 360 degrees, right? But if your angle mode is set to radians, then you may just choose negative 2 pi to positive 2 pi, okay? And the one that says step, right? That's basically asking what is the difference between each input that you want to plug in. So, you may choose 1 here and maybe 0.001 or 0.1 for that. So basically, they will be plugging in every single degree here and every 0.01 radians here. So check the window, guys. Your window must be set accordingly to your mode. It changes, the values must change depending on what angle unit you're using. Okay? as well. All right. So if you just, check out the details, the graph will just pop up like that. It's actually quite interesting graphs. And it's very, very important when it comes to AP Calculus. Oh, I mean BC only, not for AB. And it's quite fun. The graphs are rather pretty. Anyways, however, I've been saying BC, right? Meaning for SAT subject tests, they do ask you to find the graphs, but the graphs are very, very simple. Usually looks like a circle or an ellipse, and you just need to find out the correct shape of the graph, which your calculator will show you. Just don't get confused between a circle and an ellipse, all right? Mark the points, or better yet, if you're not sure how to compare between the two, if you go to Zoom, there's a button that says Zoom Square, and the button, what it does is it equalizes the scale for X and Y, because usually your graph is horizontally stretched out because the screen goes like wider, right? But if you click on Zoom Square, it equalizes the scale for X-axis and the Y-axis, so that if it's a circle, it will look like a circle, not, an ellipse. So don't forget that too. All right, now, so graphing is one of the questions that they ask, which you can simply do by using your, fancy calculator. Though, they might, ask you to convert these XY equation into polar equation. This, though it looks really quite complicated, is actually rather easy, as long as you remember these two rules. Remember, how we got this formula from graphing a right angle triangle using, r and theta as hypotenuse and the angle? Okay, here we go. X, right, is r cosine, so we square that. Y is r sine, so we square that, which will give you r squared cosine theta squared, right, plus r squared sine squared. That equals to 4 technically. That's how you convert it. However, we can't just keep it like this. We have to use other details that we know about sine and cosine to simplify this. You do know that when you factor out the x squared, the remaining terms, the sum of sine squared and cosine squared, based on the identity, should equal 1, right? Hence, the whole thing converts, into r squared equals to 4, meaning that the r is plus or minus, 2 technically, right? Though positive 2, r is distance, it's negative 2, changes. But anyways, that basically means that this will be giving you a circle. And if you think about it, this is a circle equation. And if you think about it, that's a circle equation with center at 0, 0 with radius of 2, right? So radius is 2. It makes sense, right? This is how you convert. It's actually really, really simple, as long as you remember what x and y are equal to. However, you have to use the identity along the way. The thing is, though, identities that we usually use here is simply the sum of x squared and sine squared and cosine squared being equal to 1. So I don't think you will have trouble remembering this identity, right? It's the most common one. All right, so let's do the second example. Saying exactly the same way, r cosine squared, right? They're both squared. Minus 2 r cosine, okay, y squared, so plus r squared sine squared equals to 1. So this and this added together will give you 1, okay? And that, there's nothing we can do about it. So we keep it and we put 1. So, you may continue further with the calculation of r squared times 1. So technically it's r squared minus 2, these two together, sorry. The sine and cosine becomes 1, but still has r squared outside, right? So this is what you're looking for. The SAT subject test do not expect you to solve this for the R. They don't ask you for that. This is what you're looking for. So just simply convert, but however, the converting the point, the coordinate is the most important part that you have to understand. Well, graphs, just don't forget to check your window. Those two are the most popular questions. While the solving equations part is actually more of a BC material than SAT subject test. All right, so this is the end of polar coordinates / equations and graphs. Please understand them and know how to use the calculator. All right, thank you.